Hello, students. Mechanical dust collector, also called dust collector, remove or replenish solid from gas or liquid particles according to the dust removal mechanism, mainly divided into mechanical dust collectors, electrostatic precipitator and bag filter, wet dust collector, etc. Mechanical dust collector usually refers to the use of mass force, action of gravity, inertial force and centrifugal force, a device for separating particulate matter from airflow, including gravity settling chamber, inertial dust collector and cyclone dust collector. I will mainly explain it from the following three aspects. September 2013, the State Council issued an action plan for air pollution prevention and control. 10 measures, also called Atmosphere 10. Article 1, strengthen comprehensive management, reduce multi-pollutant emissions. From a personal perspective, residents' awareness of environmental protection has been greatly enhanced. Numerous talents in the field of environmental protection. Devote yourself to the efforts of atmospheric environmental control. The next course, we will explain to you from several types of dust collectors. Treatment of dust. Here are some pictures of mechanical dust collectors. Gravity settling chamber. It takes advantage of the different densities of dust and gas. Make dust rely on its own gravity. Natural subsidence from airflow. One of the simplest dust removal devices. The basic structure and dust removal principle are: dust containing airflow enters from the inlet pipe. When the settlement chamber is much larger than the cross-sectional area of the pipeline, the gas flow rate is greatly reduced. Larger dust particles are in the settling chamber. There is enough time to settle down due to gravity. Then please think about the following two questions. 1. What is the classification dust removal efficiency of gravity settling chamber with known size? Can the actual gas to be treated meet the treatment requirements? 2. For the actual gas to be treated, the particle size and particle size distribution of dust are known. How large a gravity settling chamber should be designed to meet the processing requirements? Dust removal conditions. Time of airflow passing through settling chamber. Dust particles fall from the top to the bottom of the settling chamber. Time required. Then it can be expressed by these two formulas, which represents the length of L settling chamber. U is the airflow velocity in the settling chamber. H height of settling chamber. S is the settling velocity of dust particles. If the dust particles are not carried away by the airflow, you must have T greater than or equal to Ts. Settling velocity of particles. S can be obtained by the following formula. This formula is also Stokes' formula, where d represents the particle size of the dust particles. P denotes the density of dust particles, density of ρg gas. Mu is the viscosity of the gas. G is the acceleration of gravity. Minimum particle size of 100% capture in gravity settling chamber. You can use this formula to find. Then we often use this formula in engineering to find particulate matter larger than its particle size. Only part of it can be captured. Please think about how to improve the dust removal efficiency. The design steps of gravity settling chamber are as follows. Firstly, according to the given true density and particle size of dust, calculate the settling velocity S. Then suppose the horizontal velocity U of airflow in the settling chamber, height of settling chamber H. Then calculate and determine the length L and width of the settling chamber, or height H. Then the following formulas are used to calculate the length of the settling chamber, width, and the classification dust removal efficiency formula of various dust particles. Advantages and disadvantages of gravity settling chamber. Advantages. simple structure, less investment and less pressure loss, generally 50 to 100 pascals, convenient maintenance management. Disadvantages: large volume, low efficiency, effective capture of particles above 50 microns. It is not suitable to trap particles below 20 microns. The efficiency is between 40% and 70%. Therefore, it is suitable for purifying large particles, especially dust with strong wear performance. Most of them are used as primary treatment or pre-treatment. Give everyone a thinking question. You can finish it after class. Inertial dust collector is to use dust and gas different inertia in motion so that dusty airflow impact on the baffle plate. The airflow direction has changed sharply with the help of the inertia force of dust particles themselves. A dust removal device that separates it from airflow. There are various structural forms of inertial dust collectors. It can be roughly divided into two types: impact type and reverse type. The following pictures. It is a schematic diagram of the working principle of collision inertial dust collector. Inertial dust collector. When the dusty gas is impacted or changed direction, the higher the speed of the curvature of direction change is small. The more changes, the higher the purification efficiency. Therefore, the greater the resistance. Simple structure. The purification efficiency is not high. Most of them are used for primary processing. Particles above 10 to 20 microns. The pressure loss is 100 to 1000 pascals. Cyclone dust collector is through the rotational motion of dusty gas so that dust particles act by centrifugal force and separated from the gas. Trapping device. Dust collector diameter is less than 800 mm. High efficiency, particle size greater than 5 microns. No moving parts, simple structure, low cost, and small volume, but the resistance is great. Wear badly. After the dusty airflow enters the cyclone dust collector, dust particles in airflow be subjected to two forces in the radial direction, that is, centrifugal force generated by rotation, resistance of airflow moving with centripetal force to dust particles. When the dust is at the interface of internal and external vortex flow, the centrifugal force on dust particles is greater than the centripetal force. Then it moves down by centrifugal force and is separated to the outer wall. When the centrifugal force is less than the centripetal force, dust particles are driven by centripetal airflow. Enter the inner vortex. Leave the dust collector with the exhaust gas. When the centrifugal force is equal to the centripetal force, due to the influence of various random factors, the dust particles in this state are separated or entered. There is a 50% chance that the inner vortex will be brought out. The dust particle size with the dust removal efficiency of this classification is 50%. Divided particle size called cyclone dust collector. On the basis of determining the split particle size, it can be calculated by the following formula. Classification efficiency of cyclone dust collector. Resistance coefficient of dust removal device. It is related to the form of dust removal device. The size is related to the movement state of smoke. This formula. The pressure loss of cyclone dust collector can be calculated. Thoughts. Split particle size of a cyclone dust collector. PC equals 6 microns. The particle size distribution of dust at the inlet of dust collector is as follows. Try to calculate the classification efficiency and total efficiency of the dust collector. There are two main factors affecting cyclone dust collector. 1. The form of inlet and outlet of dust collector. 2. Proportional dimensions of dust collectors. Its proportional dimensions include the diameter of the cylinder, diameter of discharge pipe, height of cylinder and cone, and the diameter of the dust outlet. 3. Tightness of bottom of dust collector. 4. Inlet wind speed. General inlet gas velocity. It should be controlled between 12 to 25 meters per second. 5. Physical properties of soot. When the density and particle size of dust increase, the efficiency of the dust collector is obviously improved. While the temperature and viscosity of the gas increase, the efficiency of dust collector decreases. Selection of cyclone dust collector. 1. According to the dust concentration of gas. Properties of dust, separation requirements, allowable resistance loss, dust removal efficiency and other factors. Reasonable selection of cyclone dust collector model and specification. 2. According to the allowable pressure drop when the dust collector is used. Determine the inlet gas velocity. This formula can calculate the inlet gas velocity. 3. Determine the inlet cross-sectional area of the cyclone dust collector. Entrance width and entrance height. We can also use this formula to calculate. 4. Determine the geometric dimensions of each part. This table is the corresponding inlet width of many cyclone dust collectors. Relationship diagram of height, diameter and length. Selection of cyclone dust collector. Designers can choose other structures as required. However, the following principles should be followed. 1. To prevent short circuit of particles. Leak to outlet pipe. When H is less than or equal to S, where S is the depth at which the exhaust pipe is inserted. To avoid excessive pressure loss, B should be less than or equal to 2 parts. Democrat DC. 3. To keep the terminal of eddy current inside the cone. H plus L is greater than 3D. 4. In order to facilitate the dust to slide easily, the cone angle is equal to 7 to 8 degrees. In order to obtain the maximum dust removal efficiency, D to be between 0.4 and 0.5. H plus L divided by D should be between 8 and 10. SD equals about 1. Let's call it a day for this class. Thank you all.